Okay, so hi, I want to create a short-ish, hopefully, video that explains roughly how to convert between a non-deterministic finite state automaton, oh wait, no, a non-deterministic finite state automaton, and make that into a deterministic finite state automaton. Hopefully you already know what the differences between these are, but very briefly, a non-deterministic finite state automaton looks like this, where you have like two labels coming off a node, and they are labeled with the same thing. So, for example, this one, you can go from A, and then you can go to either of these two nodes, and the computer doesn't actually know which of these two nodes to go to, and anything can happen from these. And, you know, it looks kind of tentacle monstery. That doesn't matter though. But basically this is bad. You don't want this to happen. What you want is a deterministic finite state automaton, which looks like this. So it's got like one label, A, that goes to some node, and that's fine, that's great, that's wonderful. And maybe B comes off here, maybe C does, you know, and they go to their own respective nodes, and that's fine. Okay, so now what I want to do is to show you, like, the first step as to how to convert your non-deterministic finite state automaton into a deterministic finite state automaton. And in true Blue Peter style, here is a non-deterministic finite state automaton I made earlier. So it's pretty easy to tell that it's non-deterministic. You can see like A comes off here twice, they go to different places, A comes off here twice, and B comes off here twice, you know, that kind of thing. So what we want to do is to create, first we want to create some table that looks like this. So we've got state, so which state are we coming from, and then which labels does it follow, and which set of nodes does that actually go to? That is what we want to find out. Okay, so let's see here. From the first state, where does A go? A goes to 2 and 3, right? So we just create a set 2, 3, done. Okay, and B, nothing goes to B, so what we want to do is create, we want to say it goes to the empty set, because it doesn't actually go anywhere. Empty set of values, it makes sense, right? Then, so that was state 1, sorry, I probably should have created that. For state 2, where do we go? From A, we can go either to back to 2, or we can go to 4. And for B, we can only really go back to 2. For the third node, only B's, so, you know, empty set here. And the B's go to, let's see, B goes back to 3 or to 4. And our accepting node, our accepting state, here, 4, that doesn't actually go anywhere, so, you know, empty set, empty set. I think that's right, yes. Okay, so the next thing we need to do is to create yet another table, which, yeah, okay, we need to create another table, and if I can find the correct brush, it looks like this. So we've got the state that we want to call this, where it goes from A, and then where it goes from B, where it goes to from A and goes to from B even, and where it was from originally. So that original or something. Yeah. Okay, so first state we can create, this represents state 1. The first place A goes to is a state that represents 2, 3, but we're going to create a new state to represent that. So we'll call that 2. That'll be 2, 3. And so we just say that now goes to 2. As for B, we have to create another state which represents our null set. So let's call this guy 3, and we say that was originally the null set. Okay, so we can now say that B goes to this new state 3, right? Well, let's write that a bit more nicely. Okay. Now from state 2, which is 2, 3, that's state 2 in this table, 2, 3 for each A, for example, is going to be the union of the states 2 and 3 here for each of these columns A and B. So you can see here that for A, we take the union of 2 and 3 here, that's these two things, and when we take the union of the empty set and something else, it will just be what that something else is. So in this case, the set of values will just be 2, 4. So we have to create that again. 4, 2, 4. 2 will now go to 4. 2 will go to 4. B, in this case, once again, will take the union of 2 and 3. It's here, so it will be 2, 3, and 4. You can see that? 2, 3, and 4. So once again, we have to create another state. Don't worry, we'll stop creating sets eventually, but for now we have to keep creating new states until eventually we have to stop doing that. And it'll be obvious when, so that's okay. So this now goes to state 5. 3. Now, because this guy's the null set, basically we say it can only go back to itself. And an important thing to note is that means that it cannot actually go anywhere. It can't terminate properly. This is bad. Yeah, let's go 3. I know numbers. Also, one thing I'm gonna do, because 4 is an accepting state, any of these sets which include 4 are also accepting states. So, here, these guys are both accepting states. That's all that means. Sorry, these tables run together a bit, but I'm sure you can follow. Anyway, 4. Well, let's have a look at 4. What does 4 represent? The union of 2 and 4 for each of these things. Okay, so let's have a look here. So we've got 2, 4. And once again, we do 2, 4 and the empty set. So what we've got here is just 2 and 4 again, so 4 goes back to 4 for all values of A. Well, for A, because, you know, they're all... Okay, and so now where do we go from B, from 4? Well, if we have a look at this, we have to take the union of 2 and 4 from this table, so, you know, got 2, if I can write, 4, and what values do we get there? We get 2 and the empty set, so that's just 2. We don't have a state for that, however, so let's create one. Let's create this state 6, and create this, well, we say that was originally from the set of 2, from this table. You know, right, I hope you know. Right, so to pretty obvious where B goes to now. We've just created this state for it, so it goes here. 5, where does 5 go to? That's the union of 2, 3, and 4. Fortunately, that just works out to be 2 and 4 because it's the union of 2 and 4 and the empty set and the empty set again, so that's convenient. It's good. Right, where's... I'm going mad. I don't like making these tables. If you couldn't tell. So, yeah. So that goes to 2 and 4, which is state 4. State 4. Now, 2, 3, and 4 for this. So, it's the union of the set with 2 in it, the union of the set with 3 and 4 in it, here, here, and the empty set. So, that just works out to be 2, 3, and 4. 2, 3, and 4. So it goes back to itself. Because you can see that here, original 2, 3, and 4. There you go. See, I have to think about these things. I'm human too, apparently. And then, what have we got here? We've got 2. 2 goes to 2 and 4, and nothing else, you know, taking the union again. You can see that, right? So, goes 2 and 4, so that's 4 again. Quite a popular node in our upcoming finite state automaton. And we've got B here. B goes to, B will also be whatever's in 2, and it just goes back to 2 apparently. That's nice. So it goes to 6 in this case, because the original one, you know, we looked that up here, goes to 6. There you go. Okay, so wait, a slight correction from the last part. When I said 6 here, because the original is 2, I shouldn't have said that there was that you should take the union between 2 and 3 or whatever it was. I said you should just take it from whatever 2 is here. Okay, just making sure that's clear. Right. Now then, I can basically get rid of all of this, because we just want to draw our finite state automaton now. Our hopefully deterministic finite state automaton that will hopefully work perfectly fine and exactly as we expect it. So let's get started on that. Let's create our first state. 1. Where does that go? Basically, we just read off this table. We make states as is appropriate for them. So, you know, got A, that goes to 2. Got B, which goes to 3. Let's go from we've got 2, so 4. 2 goes to 4. And by B it goes to 5. Let's see, we're slowly starting to build something up here. Really hope I've left enough room, because I'm just doing this on the fly. Through... So what now, Joan? You go to 3, and 3 goes to 3, and A there, and B there, and you might notice you just get stuck there, so turns out we don't actually need this at all. We can get rid of it. It is meaningless, because it'll never accept anything if it goes there anyway. Let's get rid of it. Sayonara. Now what? So our next state is 4, right? 4. I don't want the eraser out anymore, but we go to 4. And that loops back to itself. A. And it also goes to a new state, 6, via B. 6. So now 5 goes to 4. Oh, I'm left a lot of room for this. Oop. 5 goes to 4 via A. go, sound effect again, and then these repetitive things make me go mad. Let's see here, what state have we got left? We've got 6. 6 also goes to 4 via A, and 6 also goes to B. No, 6 goes to itself via B. There we go. Okay, and very quickly, no, in fact, I'm going to make another one. And you know, to finish this off, we have to, well, let's look at state 5 again, because I kind of overlooked that it links back to itself. B there. Oops, I'm selecting things. I think it's B, there you go. And finally, what we want to say is, these guys are accepting states. Right, now let's real quick verify, hopefully, that the automaton works as... You didn't see that. As expected. Right, so let's come up with some accepted strings that are accepted by our nondeterministic finite state automaton. That's this guy. No, we don't like him. He's bad. We like this guy. What am I even saying anymore? Right. We've got, for example, A, B, A. And A, B, B. Yeah, and just A, B, B. Let's be simple about this. We don't need really long strings. Let's see, A, B, A. And let's come up with some not accepted. It's kind of awkward to do with a non-deterministic automaton, but let's try it anyway. So we've got A, for example, just A by itself. We've got, I think, A, B by itself also shouldn't be accepted. A, B. But A, B, 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 A will be accepted, I believe, because of this bit here, even if it doesn't look like it will down here, which I was having a little trouble with earlier. It's fine though. Anyway, we've come up with some not accepted strings. As an exercise to yourself, why don't you come up with some? Right, so let's check these. A, B, A. We can see that works. A, B, A. And we end up in an accepting state. Again, A, B, B, A, B, B. Right. A, B, B. A, B, A. A, B, A. Yep, we end up at 4. And not accepted. Just A. We end up at 2, so no. So that works out. And A, B, A, B. Yeah. Excellent. We can also work backwards, I guess, if you haven't gotten bored of me checking things by this point. We've got A. Let's see here, what won't be accepted? A, B... A, B... A, B? A, B, A, B. Let's try that. A, B, A, B. I hope for my sake that this doesn't actually work. A, B, A... There's nowhere to go from there. A, B, A... Nowhere to go from there. A, B... Nowhere to go from there. I think that's looking pretty not accepted. Excellent. So, it seems at least that these two are equivalent. Enjoy applying that to your own non-deterministic finite state automata, whatever. Finish.